All right, everybody, today we have a new set of notes, linear transformations. As always, make sure that you take care of your attendance quiz and update your table of contents. All right, so we need to know what these linear transformations are. So everything you see on this slide, you need to go ahead and write down. Linear transformations are where I take my parent function and I shift it into a different direction, okay? For instance, on top here, we see the transformation moving up. So whenever you add or have a positive y-intercept, your line is gonna move up. So from the black line to the blue line, our transformation is up 5. Whenever you have these type of transformations, you must go ahead and say the number of how much it moved. So again, in this case, it would be up 5. Now, equation-wise, what it's going to look like is you're going to have this f of x equals x. Remember, this is the same as y equals x. They are exactly the same, f of x and y. There is no difference besides one is y, the other is f of x. F of x just means that we have a function. This is definitely a function. Now, when I have a second function, we're going to go ahead and name this g of x. And what we're saying here is g of x equals whatever f of x is plus 5. But what am I really focused on? This plus 5, because that tells me that I'm going up 5. So if I was asked what transformation occurred, I would say, well, my line went up 5. Now down here below, here I have down 5. So when my line went from f of x equals x, in other words, y equals x, to g of x equals f of x minus 5, that meant that my line went downwards, okay? So whenever you subtract or have a negative y-intercept, that's when your line is going to go down. And again, you want to write all of this down. Have all this information plus the graphs. All right, so let's do some practice here, okay? So first off, what transformation occurred from f of x equals x to g of x equals f of x minus 9? Well, that would be down 9. What about f of x plus 4? That would be up 4. Pause the video and you try the next two. All right, for the next one, f of x plus 7 would be up 7, and f of x minus 15 is going to be down 15. All I'm looking at again is this number right here. If it's negative, I'm going down. If it's positive, I'm going up. All right, next. The next two sets of transformations that we have. Steeper and less steep, okay? With steeper and less steep, what's changing is my slope. Notice on both graphs, the blue graph here, my black line is still my parent function. The blue line is my steeper line. It's getting steeper, it's going up, but it's only the slope that's changing here. So when the slope changes to be a higher slope, that's when I'm going to be steeper. So in other words, when my slope is bigger than 1, my line is going to be steeper. So on my equation, if I have a 3 f of x, that means that my slope is bigger than 1 and I am steeper. But on the other hand, if my slope is between 0 and 1, like this one here at 1/3, then my slope tells me that I'm going to be less steep. Okay. Now, negative does not make the decision of being less steep. A negative number does not tell me that I'm going to have a less steep slope. Negative is actually going to be a different transformation. But again, before I move on, you want to make sure that you go ahead and get all of this written down in the sketches of the two graphs here. All right, so next thing you want to do is go ahead and write down reflection. What a reflection is. This right here is whenever I have a reflection, that means my slope is negative. Okay, so if I have a negative f of x, that tells me I have a reflection, and while my black line here is going in the positive slope direction, the green line is a negative slope. So negative slope is a reflection, positive slope is not. All right, again, let's do some practice. So 8f of x, what is that? I have a slope that is bigger than 1, so I am steeper. What about 0.5 f of x? Well, that slope is less than 1, bigger than 0, and so that makes it less steep. All right, you try the next two. All right, 4/3 f of x. What is that one? That one we should have put steeper. While it is a fraction, 4/3 is bigger than 1. And then 50, what is that one? 50 is steeper as well. If I had, for instance, g of x equals 1/3 f of x, that would have been an example of less steep. Now, we've seen mainly ones where they only have one transformation occurring, but sometimes we're going to have more than one, and a lot of times that's going to be the case. So whenever that happens, you name every transformation that you see happening. So what I do is I start at the very first one. First thing I see is that my slope has changed. My slope is bigger than 1, so that makes it steeper than my parent function. Well, then I also see that I have a -2 here. So I'm subtracting 2, meaning I'm going down 2. So now let's try the next one. I have a slope here that's bigger than 1. So I again am steeper. But this time I am adding 1, so I'm going up 1. All right, you try the next two. All right, so on this first one, I have a slope here that's not 1, it's 1/4. That means I'm less steep. All right, and this other one here, -6, it's subtracting 6, so that means it's going down 6. Next problem. Oh, I got, it's -50. Well, the 50 tells me that I'm going to be steeper, actually. Don't let that negative fool you, because remember what we just talked about. The negative here tells me that I have a reflection. And then last but not least, I still have this +7, which tells me I'm going to go up 7. So while sometimes I'm going to have one transformation, sometimes I'm going to have 2, other times I could even have 3. Okay, it is possible to have 3 different transformations for a linear equation. So you have to make sure for each equation that you name every single transformation that could possibly be occurring. All right, guys, that is it for notes for today. Go ahead and go back to your module and work on today's check for understanding. And then on tomorrow, we will go ahead and go over those answers. All right, so go ahead and go work on that. Have a good rest of your day. See you guys tomorrow.